Hey, hello. So there's a trend to say that everything that is written in Rust is faster and safer and whatever. I agree with safer, depending on how the program was written. In terms of fast, it depends. So I came across this funny tweet where someone is saying that their sorting algorithm is faster than somebody else, as professor claims. So that's the first layer of stupidity. Then the person is claiming that his fast algorithm was written in C, another layer of stupidity, kind of. Then the professor or the person who knows better actually puts a final touch on a person, and he made something in Python, and it turned out to be faster than whatever the C developer claimed. So what this basically says is there's a right tool for the job. So in previous sessions, I attempted to rewrite my goal-oriented algorithm, which heavily works with dictionaries. This is supposed to be a very configurable portion of the application, um, which would come from, I don't know, backend or not. There might be more keys added to it, some random scheisse, whatever. So I have rewritten what I had in Rust with the same mistakes in Python, right? And as I always do, I try to run the thing a bunch of times in on both platforms. So the same 1,000 iterations of the same data, of the same dictionary or hash map. And when I ran the Python 3.8 of the algorithm, as you can see, it takes like uh, yeah, it takes 246 milliseconds. It should have written me a nicer output. All right, okay. So it takes 200 milliseconds, and the same thing in Rust in release mode. It took 434 milliseconds. So you can obviously see that Rust, for some reason, is slower. And at first, I really started to dig into whether my Rust code implementation was incorrect or something, which probably is so, but I wrote the thing in a naive manner, as all developers do. And I decided to actually play around with the speeds of accessing data from a dictionary or hash map. So if I step into other test I had, which is so I know that there's a world state data, which it is a hash map. I always access things by keys in the algorithm. So I concentrated on getting data alive or ready for peace or alive 100,000 times, right? And I iterate the keys and I access the things in a dictionary by key a bunch of times. So this simulates work that I'm really going after some serious data in the code. And this particular case of accessing several keys from the dictionary 100,000 times is taking up. So it took uh, almost 2 milliseconds. Yep, consistent. And now, if I access the same logic, as you can see, run map access, run map access, with the same keys, with the same for 100,000 times. Yeah, it's actually the same code, right? Running that in release mode, we can see it takes like 6 milliseconds. So obviously a dynamic part of accessing data by key from a hash map or a dictionary in Rust is way slower. Why is that? Well, obviously Python, it did go through some changes from version 3 to 3.8, which is what I am testing against, and they sped up a few things. But whenever we access data from a dictionary, the string we use in here is no longer just a string. It's some sort of index already, internal indexes or optimization method that the Python or JavaScript for that matter implement, because they are the garbage collector things and they work towards increasing the speed of their code. So we're not accessing data by key in there. We kind of they incorporate some hacks in there to speed up access to hash map, and let's point it out, hash map thing. So they made it fast. As for Rust, had I not used a hash map for the dictionary of a world state, had I used compiled structure like JSON Serde would have a list of booleans or whatever, it would wipe the floor with Python. I mean, Python would have no chance with it, right? But I worked with a naive thinking that even accessing dictionary by key in Rust or hash map by key in Rust would be way faster. And I was wrong, because again, Rust works in a very raw approach. It does only the thing that you ask it to do, whereas Python and JavaScript and other interpreted languages, they have to have some hacks to make the code run faster with all the slowness that they provide. Um, which makes me believe that, yeah, working with dynamic parameters like that in Python would make more sense, because we're not doing mathematical equations in here, and I guess in data science, yeah, they access stuff so frequently with keys, and they work with dictionaries so much that Python developers just had to come up with ways to increase or decrease access speed to the items in the compiled JSON structure into dictionary, so that the workflow of scientists would be faster. So this particular case where I had to go in and use the map to test a bunch of things, and I'm doing a lot of things in map, like checking for uh, where is the get function in here? Get, is this the only place? Or has hash map? Copying. Yeah, I'm also copying a lot of hash maps. I have to just to create submaps for specific nodes in the goal oriented uh, planning, action planning. So this is heavy shit that Rust would not be faster at than Python. Of course, Python would use more memory for all the optimizations I just mentioned, but the point is for one-time operations or I don't know, repeated operations, I understand Python would not hold how to put it. If I had tasks on Python machine to constantly day and night operate with data like this, I would need to have a computer with more RAM to process the data than the slower, as it turned out to be, a version of Rust processing the data. So Rust would use less memory, RAM memory, but more CPU power to process the thing. So there's the trade-offs, right? Apparently, yeah, data science people, I have huge respect and happiness for you that you can use this nice optimized language. And I'm also happy for me to use JavaScript or TypeScript at work because all the data optimization was done for us. Whereas in Python, Rust, again, I already started thinking about indexed maps so that I would convert it to a array so that my data access would be faster and simpler. But this is already more code than any developer would want. So there you go. I kind of feel like a fool thinking that my Rust code would be faster just because it's done on a machine level without any interpreters. But with all the trade-offs in mind, there's some things that should remain in interpreted world, and we shouldn't be way too crazy about being at low level. There you go. I hope you liked it, and yeah, you have to know more just to know which tool to use. See you next time.